Good morning, everybody. Last time we made our discussion well into the concept of polymorphism, and I talked about this example from some other source. Actually, it is the same example that our textbook gives, but it is kind of more detailed, and it demonstrates the idea of polymorphism a little bit better, more explicit. So let's remember the classes. We had 5 classes. At the top, we have our employee class. By the way, how is my synchronization today with the sound and the display? Am I late? When I say 1, 2, 3, 4, 5, 6, 7, is this good?
There is no delay, sir. There is no delay.
There is no delay. Okay, good. So they fixed it on last week, I guess. Okay, so 5 classes, and this is the class hierarchy. I have drawn it. I drew this here. And as you see, everybody derives from employee, and we have commission employee derived from employee, and base plus commission, it derives from commission employee. Okay, so and I think I have shown you the most of the code. I was looking at the derived code, but let's look at some of the important concept in this code. And the employee is of course important because our employee is a abstract class. Why do we call this employee an abstract class? Let's go to the class definition. We call this employee an abstract class because, okay, somebody tell me why. We call employee an abstract class because
it has pure virtual function.
It contains one pure virtual function, right? So this is earnings is a virtual function, but it's a pure virtual function. What do we mean by pure virtual? It is pure virtual because we told the compiler that at line 24, we told the compiler that we are not going to implement it. There will be no implementation. Since employee is an abstract class, nobody can make objects of employee. So employee is a special class. I mean, for some of you, it might come as a surprise. There are classes of which you cannot make objects of. Okay, this is something different. Why I cannot make an object of employee is because some of its functions are not implemented. Okay, their headers are fine, but implementations are not there. So I cannot make objects of them. Print function is a virtual function, but its implementation will be provided for the class employee. Okay, class employee is a simple one. It takes the name, last name, and social security number of the employee, and there are usual setters and getters, and that's it. Okay, so employee class is like this. And implementation, I am not going to look at the implementation. It is trivial, and last time we looked at it. By the way, when we implement this virtual function print, we don't write the keyword virtual at the beginning for the implementation. Okay, it is only for the class declaration. Okay, good. I think this one doesn't, yeah, this one doesn't use the namespaces, which is a bad thing. Okay. And the salaried employee is an employee. It says that I am going to implement this earnings function. It doesn't say anything about the pure virtual. So this is going to again, it is virtual function, but it's not a pure virtual function. And implementation is here. It's just my earnings. I now know how to implement this earnings function. Okay, the earnings for a salaried employee is simply weekly salary. That's it. And the print function says that, okay, apart from the employee part, which is line 39, apart from the employee part, what I'm going to do is I will get the weekly salary and I will print it. That's it. That's my print function now. Okay. So I have 3 more classes like this. Okay, it is hourly employee. Hourly employee again derives from the employee, and on top of it, on top of employee properties, employee features, I add wage and hours. And of course, I am going to override, not redefine, but override. Remember override? Okay, override is different from redefinition. Okay, I am going to override the earnings and the print function. Okay, so they will be done. And then what I have, commission employee. Commission employee adds to these 2 data members, gross sales and commission rate, and getters and setters for that. Earnings is going to change accordingly. And our final class is the base plus commission employee, which is derived, okay, from commission employee, not from directly from employee, but from commission employee. Okay, so I completed all of my implementation, and here is a simple note. I said that you cannot create objects of employee class, E1, E2. No, you cannot, because employee is a abstract class. It's an abstract class. So where am I going to use employee? I am going to use it as a base class. That's one thing. The other thing is the fact that I cannot create objects of employee doesn't mean that I cannot declare pointers of employee. It is fine. A pointer employee is not an employee. It is just a pointer. So I can create here pointers of employee class. So where am I going to use it? I can use it in this kind of assignment operation. Why? Because hourly employee is an employee, right? So I can treat the hourly employee objects as employee objects. So I take the address of this hourly employee object and assign it to this employee pointer. Okay. Assign it to this employee pointer. Okay. After that, what can I do with this? Let me move this aside. Let me move this aside here. Okay. And then let's do this. Of course I could say cout EP get name. No problem. This is okay. No problem. This is okay. How about this? Cout EP print. Would this work? Let me continue while you are think about it. EP earnings and C out EP get hours. Remember, this is an hourly employee. Okay, let's look at this one. EP print. Would this compile? Would this work? Does this line compile?
I guess yes, sir.
Of course it will compile. Why? EP is an employee pointer and there is a print function in it. And we have implemented it, right? But whose print will be called? Okay, tell me whose print will be called. This will be okay. But is it going to be the hourly employee print or the employee print? Which one?
Hourly.
Why? Yeah, that's exactly true. It is hourly employee. Why? Because of the polymorphism. Why? Because we said that print and earnings are virtual functions. The virtual functions will be decided which function to call during the runtime. Okay? EP is an employee pointer, but when the compiler sees that there is a print function called on the base class pointer, the compiler will say that I am not going to make my decision right now. I will wait until the runtime. When this code runs, I will follow this pointer. I will find the object pointed by this EP. It is an hourly employee. Then I find the print function of that hourly employee and I will call it. So this decision, which print to call, will be made during the runtime. Okay. For this one, it is not. For this one, the getName is the getName function of the employee class because everything is done during the compilation time. This is early binding, late binding. Okay. Static binding, dynamic binding. Sometimes you can say that too. Okay. Early binding because this is non-virtual function. Up to this chapter, up to the chapter of polymorphism, we have never used late binding or dynamic binding. Okay. All the bindings, okay, were done during the compilation time. Compiler knew which function to call. But this one, the compiler doesn't know it. Compiler says that I will produce some code that will make that decision during the runtime. That's why calling using virtual functions is expensive for the runtime. Why? Because during the runtime, this is not a simple function call. Your code has to figure out which function to call first, then it's going to call it. Okay, this will work. How about this line? Is it going to compile and is it going to work? Remember, earnings is a pure virtual function, and for the employee class, EP is a pointer of the employee class. Okay. Earnings function is a pure virtual and it is not implemented. Would this line here compile and work?
It's just like print function.
There is no difference, right? It is just like print function. It's a virtual function and it will be decided during the runtime because I am calling it using a virtual function calling syntax, and it will work no problem, and it will be, of course, both of them will be hourly employee print functions. Both of them will be hourly employee print functions. Okay, how about the last one? Would this compile and would this work? GetHours is a function of what? It's not a function of employee, but I know that EP points to a hourly employee. object. Any ideas? Get hours? Would this compile and would this work?
I guess yes, sir.
It will compile and it will work. Okay, well, get hours is not a virtual function. And get hours, in fact, is not a member of this employee class. So if you are the compiler, if you are compiling this code, what would you think? What would you think? It says that there is a get hours function. Okay, I'm going to call it. Whose pointer is this? It's an employee class pointer. Let's go to the employee class definition. Let's go to the employee class definition. Where was it? Let me find it. Here. Do you see any get hours function here? Do you see get hours function here?
No.
No. This is different from the previous examples. In the previous examples, I have both earnings and print functions, right? I have both of them. The compiler knows that there will be a function named earnings and there will be a function named print. Even though one of them is pure virtual, if somebody is deriving from it, it will provide the earnings function. But get hours, for the employee class, there is no get hours function. That's why the compiler will say that I cannot compile this one. I cannot compile this one. No. Why? Because employee class doesn't have a function named get hours. Okay, so this is different from print and earnings. To be able to make this kind of compilation, you need to provide these functions for the base class. Get hours is not in the base class. You might say that, well, I know that EP points to an hourly employee object. You might say that, but compiler doesn't know that, right? The compiler, when it is compiling this line, compiler doesn't know that EP is pointing to an hourly employee class or commission employee class or salaried employee class, right? EP doesn't know that. A compiler doesn't know that. Okay, this will be determined during the runtime, and during the runtime, that object may have a get hours or function or not. Okay, but that object has to have the print function and earnings function, whatever it is. Doesn't matter if it's an hourly employee, commission employee, salaried employee, base plus commission employee. All those classes should have their print and earnings functions. Why? Because they derived from the base class employee. Okay, I hope this part is clear because this will be important. Any questions on this?
I have a question.
Okay.
Why compiler can't resolve in compile time in this polymorphism thing in compile time? What's the mechanism?
You mean for the print and the earnings function?
Yes, also get hours function. Actually, not get hours, print and earnings function. Right?
Yeah, well, during the compile time, compiler doesn't know what EP is pointing to, right? Let me write this code a little bit different. But
we just assign the EP to the address of each.
The compiler is not that smart, okay? Compiler is not smart enough to go back and see, oh, it must be this way. Let me write some other code, okay? That's a good question, actually, okay? So it gives me a chance to explain this even. And thanks for asking that. Nobody's asking any questions, okay? That's good. Okay, Let me write it in a way like this. Void, it's a function, void print stuff. And this print stuff should get an employee pointer. Employee pointer EP. Okay. Parentheses. Okay, good. So that's what print stuff does. It's a very simple function. Print stuff. So the print stuff, when you compile this print stuff, Kamil, did you ask that question? Okay.
Yes.
Yeah. Okay. When you compile, you are a compiler, right? When you compile this function, if you are the compiler, you are the smartest compiler in the world. If you are the compiler, how would you know the type of object that EP is pointing to? Because you don't know how am I going to call it, right?
Yes, this is 341. I have to go to the function that is being called.
Yeah, well, I mean, in that case, yeah, even if you do that, let me make this a little bit smaller. Even if you do that, okay, call this function print_st with EP. One thing, okay, that you can do that too. But then I can do this. Let's say commission employee CE, whatever it is, I don't know. And then EP gets the value of commission employee, and I call print stuff EP. Even if you go back and try to trace your code and find what kind of thing it is, this is a simple function. You are going to produce a single set of code for this print stuff, right? But print stuff sometimes get hourly employee objects, sometimes it gets commission employee objects, sometimes it gets base plus commission employee objects, okay? There is no way the compiler can, or any other person in the world, even the designers of the original designers of the C++, there is no way that smartest person in the world can figure out which print is this, okay? You have to wait until the compile time, until the runtime. When you're running this function, you get this pointer, you follow the object, okay? You find its type and you call this print function. That's called dynamic binding or late binding, and you have to wait until the runtime. You cannot figure this out during the compile time. Get name will be figured out during the compile time because it is the get name function of the employee class. Okay. By the way, if I have redefined this get name function for the hourly employee and the commission employee, they will be ignored because get name will be decided during the compile time, and it will be the get name function of the employee class. There is no other way. Compiler cannot say anything else because compiler here it says that okay, get name is not a virtual function. I will make a decision, and decision is get name is the base class's get name function. No other exceptions. Okay. For the print and earnings, I will wait. For get hours, I don't know. What is get hours? Employee class doesn't have a function named get hours. Okay, so that was a good question, Kamil. Thank you for asking. And I hope this made it clear for the other people. Any other questions? Any other questions?
Sir, employee, if it is not an abstract class, and there is a parameter of function employee, but we send it our employee object to him, can we use it to get ours in a function?
You mean that employee is not an abstract class?
Yes.
And instead of sending a pointer, you are sending a employee object called by value.
hourly employee object.
Oh yeah, you mean the hourly employee object here.
Type conversion.
Okay, so that's another good question. You are saying that let's have another. Okay, I was going to discuss it, but since you asked it, let me take this here and let's modify this function a little bit. You are saying that I messed it up. No, okay, good. You are saying that this is print stuff 2 and this one takes an employee object, and I assume that employee is not an abstract class. That's what you are saying, right? And then so these will be dot dot dot and dot, right? And you are going to call this print stuff like this. You are going to call this print stuff 2 with an commission employee. That's what you are saying, right?
Yeah.
Okay. Yeah, the first of all, this is okay. You may call it. And this one will work, this one will work, this one will work. But if you are the compiler, what would you think?
No.
I mean, if you are the compiler, you don't know what kind of objects you are going to receive, right? I mean, you may receive an employee, you may receive a commission employee or hourly employee or any employee object. So some of them will have get hours, some of them will not have get hours. During the compile time, there is no way to resolve it. Okay, and since get hours is not a virtual function, I am not going to delay this decision to the runtime. Okay, so it doesn't matter if it's a call by value employee or the pointer employee, this will not work. Okay, we will talk about this problem. There is a problem with this, and we will talk about this problem later. I will have more things to say about this function because there is something else funny going on with this function. I mean, I was very careful to use a pointer here. Why? Because when you use a pointer, your object doesn't change. Here, your object is different. I mean, you have to ignore some part of your commission employee class object. Okay, that's called the slicing problem. And we will talk about it later. By the way, these two, okay, these two are not resolved during the runtime anymore. These are not polymorphic calls. Because polymorphic calls, okay, or the virtual function calls can happen only with the base class pointers or base class references. Okay, base class pointers or base class references. Polymorphic calls, they happen that way. These are static calls. These are early binding calls, all of them. So this is the print function of the base class. This is the print function of this is the earnings function of the base class. Okay. Since we assume that the employee is a concrete class, then the compiler will compile it that way. So all three decisions will be made during the compile time if EP is an employee object. It is not a pointer, it's not a reference. But if it's a reference, okay, we will talk about it. If it's a reference, then these two will be again polymorphic calls, late binding calls. Okay, good. If there are no questions, if there are no other questions, let me continue with the. Something is beeping here. Okay, let me continue with the rest of the example. Okay, so let's use the driver code to tell you about how the polymorphism and late binding works. See these two functions? They are on purpose written that way. One is a constant employee pointer. The other is a constant employee reference. Remember, employee is a abstract class. Nobody can make objects of employee class. So you cannot have a function like this. Employee E. You cannot have a function like that, right? Employee is a abstract class. Nobody can make objects of employee. How come there is a reference? Reference is different from the object itself. Okay, references are different. References are like pointer actually. Okay, I may have a reference to a base class, abstract base class, or I may have a pointer to an abstract base class. No problem. So these two functions, we are gonna see them later. Okay, so this is our main function. Okay, I am making objects of salaried employee, hourly employee, commission employee, and base plus commission employee, but no objects of employee, of course. And I will call 1, 2, 3, 4 print functions on these objects. All of these print functions are static binding or early binding. Okay, why? Because even though print is a virtual function, if you call it this way, the compiler ignores the fact that print is a virtual. It says that somebody is using print as a early binding function, as a regular function, because they are not using a base class's pointer, or they are not using a base class's reference. So all these decisions will be made during the compile time. Okay, so good. And then I have a vector of employee pointers, but not employees, because you cannot have vector of employees. Okay, you will have an employee pointer vector, and since there is an is-a relationship, I may assign the addresses of these 4 objects to the employee pointer vector elements, one by one. Okay, and then I am running this loop from 0 to size of employees, and I am calling this, remember this function virtual via pointer. It expects you to send a employee pointer. Yeah, I am sending an employee pointer to that one. Remember, virtual via pointer doesn't know what kind of object it is getting, other than that it's an employee pointer. That object, okay, that pointer may point to any type of employee class, salaried employee, hourly employee, or commission employee, doesn't matter. And I am doing the same thing with the virtual via reference function. I am sending a reference to employee objects. Okay, good. Okay, so let's look at the implementation of that virtual via pointer and virtual via reference. Virtual via pointer does this. Okay, it takes an employee pointer and it calls this print function and it calls this earnings function. Okay, if you are the compiler, or if you are the smartest person in the world, and some of you are, okay, and you cannot say what class this employee pointer is pointing to. You cannot during the compile time. This will be determined only during the runtime. During the runtime, I can know that. Okay, I will follow this pointer, base class pointer employee. I will find the object, and after finding the object, I will call its earnings function. The same thing here too. Base class reference. Okay, I will follow this reference. I will find its object, and I will call the print function of that object. Okay. So making this call is expensive. making this call is expensive, and making this call is expensive, because during the runtime you have to follow the pointer, you need to find the object, and you need to find its print function, and you need to call it. Previously, when we did the function calls of print and earnings, okay, during the runtime, compiler says that, okay, I'm going to call this function during the runtime. So decision is made during the compile time. So during the runtime, everything is so efficient. Your code knows which function to call. Okay, so remember why we are doing this. We are doing this because we like to be able to write this kind of generic code. This code, okay, this code will work for any type of employee class. Even though I write this function using only the employee header file, okay? Other than the employee header file, I didn't see anything, right? I know that there is a print function, there is an earnings function, and I don't know the rest. I did not see the rest of the class hierarchy. I did not to be able to write this function, I did not see the definition, implementation of any other classes other than the employee class. Okay. Any questions? I think this is a better example than Book's example. That's why I like to show this one. Any questions? Maybe if I give you the internal details of, okay, by the way, okay, these lines, when I run this program, these lines come from the static binding print functions. So these lines come from where? They come from line 43 to 51, right? So these static bindings will produce those lines. And then I have two loops. Okay, in these loops, I will call virtual via pointer and virtual via reference. Okay, so as you see, this is a salaried employee, hourly employee, commission employee, and base salaried commission employee. And then again, I am getting the same effect: salaried, hourly, commission, and base. So this is virtual function is doing this. So I don't make this decision during the runtime, but during the compile time, my code figures out which function to call. This one comes from the first loop, and this one comes from the second loop. Okay, my second loop function doesn't know anything about these classes: salaried employee, hourly employee, or commission employee. It doesn't. Good. Let me show you how the internals of this thing works. This book has a nice explanation to it. Okay. Each class keeps a V table. Use the blue pen. V table or virtual function table. Each class, if it is involved with a hierarchy that includes virtual functions, then each class will have V tables. The V table for the employee class has two entries: earnings and print. So this V table will hold pointers to virtual functions. Okay, so the earnings pointer for the employee class is null. Why? Because there is no implementation for earnings. But for the print function, there is an implementation and I point to that implementation. Salaried employee will provide two function pointers, and they will be pointing to some functions. Okay, and I will have the different earnings and print for the hourly employee, different earnings and print. So each class will have its own V table. Let's look at this vector of 4 employee pointers. In that employee pointer vector, I have salaried employee object, hourly employee, commission employee, and base plus commission employee. Okay. Let's say somebody is calling okay, base class pointer print function on this pointer. So what am I going to do? I am going to find this object. So with this pointer, okay. Let me do this. Okay, let me write the code. Employees one is this, and print. Okay, my code knows where this employee class lives, where this vector lives. Sorry. Okay, I go to the beginning of this vector. I find the first element, not the element number 0, but element number 1. I found the element number 1. I found it, and then I know that it's an employee pointer, right? It's a base class pointer. I know that. Okay, so I follow this pointer. I found my hourly employee object. Now I have my object. My object has a pointer that points to my hourly employee V table, and I find this table, which is an array of function pointers, and inside that table I search for print function, and I find that print function and I call it. So it's a 5-step process. It is expensive. Get the pointer, find the object, get its V table. Inside the V table, find the function itself, print. Okay. Remember at the beginning of the semester or some other time, I don't know, I asked you this question. If I have a class like this, class A, and I have an object of it, what is the size of A? Okay. So you might think that it is 0 because there is nothing in it. No. Okay. Each class has these kind of pointers. Okay. Each class has these kind of pointers, even if they are empty, and they have some other information in them. Each class object, even if it's an empty class. Okay. So one of the things that you keep in your objects is that kind of a pointer. Okay, good. Any questions? So this is a nice example, nice explanation of what's going on with the virtual functions. If it is not a virtual function, then during the compile time, I know which function to call. You see, I have to follow these links 1, 2, 3, 4, 5. Now I am calling this hourly employee print. If it is not a virtual function, then during the compile time, I already know this function. I just call it. Okay, so I don't have to follow any of these steps. Okay, let me go back to the original our books slides. Then I will come back and I will give you one more example from this one, but let me go to our book slides because you are reading the book and I don't want to okay, good. So the book has this class example.
Can you put previous slides to the teams?
You mean you don't have those? Can I find it? Let me try to find those slides. Where are the slides? Where did I put them? Okay. PowerPoints. Okay, did you get the
Yes.
did you get the file?
Yes, thank you.
Okay, thanks for reminding that. Okay, the book talks about this class hierarchy that I gave you before. Remember the class hierarchy that I have drew on the board like this, and we talked about the inheritance. Okay, the book talks about this, and in my base class, I think in that case I had two virtual functions, pure virtual functions. One of them is the area of the shape, the other one is the perimeter of the shape. Okay, so this is my abstract base class, pure virtual functions, and my rectangle and the triangle and the square, they are all overriding these area and perimeter functions. That's good. I think I gave you this example, and I introduced the idea. I introduced ideas of virtual and non-virtual, late binding, early binding, static binding, dynamic binding, and abstract class and concrete class. So in this chapter, you learned how to write virtual functions and pure virtual functions. You know how to do the late binding, and you know how to write abstract classes. Previously, we had been writing, okay, non-virtual functions or static functions. We were doing early binding all the time, and we were writing concrete classes. Somut sınıflar, soyut sınıflar. Somut, soyut. Okay, so we have been writing concrete classes. Good, and the book gives this example about these figures, so I will skip this because I did it a little bit differently. The book, okay, says that, okay, you tell the compiler with the virtual functions, don't know how the function is implemented yet. Wait until it is used in the program. Then you get the implementation from the instance. What do I mean by this? You follow all those pointers, and you find your print function in that V table. It's called late binding or dynamic binding. Okay. Another example for the virtual functions, I will give you this. Automobile parts or any other parts. You are making a sale, okay, and for each sale, okay, this is the very simple class. A sale, satış, okay. For each sale, you have the price and you have the bill, okay. You might say that what is the difference between price and bill? Price, fiyatı, bill, fatura. Okay. Price is different from bill because when you write the bill, when you write the fatura, you might add some taxes, or you might do some discount, like 10% off for some promotion and etc., or 50% off. Okay, so you are discounting some money maybe. So the price is the regular price of the object that you are selling, the item that you are selling. Bill is the amount of money that you are charging, that you are writing on your bill. And savings is comparing two sales. Which one is larger, or what is the difference between them? So this one will call the bill function of two objects, and it will find the difference. See, the bill is virtual. That means that we are going to use this class, which is a concrete class, by the way. It's not abstract class. We are going to use this base class, okay, to derive other classes, to make derivation out of this class sale. Okay, so this is the implementation of the important ones. Savings function takes a base class reference, and other.bill is going to be a polymorphic call, late binding. Why late binding? Because it is using the base class's reference. To do the late binding, you need a few things. One is you need to call the virtual functions. Okay. The second one is you need to use a base class pointer or reference. Okay. So bill is a virtual function, I know, and other is a base class reference. So this is going to be a late binding. I will make this decision during the runtime, not compile time. Okay, and the same thing here again, operator less than. This is a global function, and it takes two sale object references, and it calls the bill function on of them. Okay, so these are base class references, and bill is a virtual function. Okay, so every bill function that you see in the slide is a late binding example. So it doesn't make sense to talk about this. Okay, I mean, if all you have is this class, sale class, okay, if all you have is this sale class, then I know that these bill functions, they are all bill function of this sale class. I know that, but the compiler doesn't know that, right? The compiler doesn't know that if somebody else is going to derive another class and call this function or that function using the objects of that class. Okay, that's why compiler has to produce the late binding code. Okay, so let's write another class, discount sale. Discount sale is a sale class. Okay, of course it has its constructor. It says that what is my price and what is the discount. Okay, by the way, this is the discount. There is an hyphen there. Let me use the black pen actually. Okay, so it's an identifier. So get discount is a new function, set discount another new function, and I am overriding this double bill function, which is a virtual function. I don't touch the other functions of the class sale. Okay, so let's look at this definition of discount sale bill. It says that my bill amount is going to be price times 1 minus fraction. So whatever the discount is, let's say if I am saying 10% discount, then 1 minus 0.1 times price will be my bill amount. Okay, so this class is doing that, and let's look at the why don't I use the Notepad to, where is my map? What's going on? Oh, it looks like I am way out of time. Okay. Why don't we get 10 minutes of break? After the break, we will continue, okay? 10 minutes of break. After the break, we will look at this code. 10 minutes. $11:36. Aleykümselam hocam. Şimdi derse gireceğim tekrar.
Nasılsın, iyisin?
Şükür valla. Uğraşıyoruz işte.
Aa,
Ne taktın yüzüne öyle?
ha?
Ne taktın öyle yüzüne?
Vallahi ne bulursam onu takıyorum. Sen böyle ıslanıyorsun anlaşılan.
He?
Örtmüşsün oraları.
Ya tedbir olsun diye koydum ya. Belli olmuyor yani.
Ha. Ya ben şu şeyleri print out edeyim.
Tamam.
Zımbırtıları. Sen yenisini hazırladın mı? Yeni.
Yok hazırlamadım ama yapacağımız sadece o şeyi oraya koymak.
Onları koydum ben ama
Hı hı.
kontrol kumanda da neyse ikincisinde iki adam da 65'in altında. Yani bu durumda şey oluyor.
Evet.
Öyle mi göndereceğiz?
Öyle gönderdim evet.
Tamam. Yani başarısız diyoruz ikisine de.
Hı hı.
Diğerinde birisi asil, birisini yedek diye gönderiyoruz. İkisi de 65'in üstünde.
Tamam.
Bir tanesi
Ne kadar aşağıda kalıyorlar?
çok az. Bakalım mı? Bakmak istiyor musun?
Şimdi derse gireceğim ya.
Ha, yani
Çıkınca ben bir bakalım beraber olur mu?
tamam ben print edeyim. Olmazsa düzeltiriz.
Evet.
Ama
Olmazsa ben bir arayayım gene sekreteri.
durum böyle diye. Ben onları bir print edeceğim. Eskisini print edeceğim. Yenisini print edeceğim. Bir de benim yazdığım 2 tane raporu print edeceğim. Hepsini imzalayacağım.
Raporları da göndermemiz gerekiyor öyle mi? Bir de bir şey
Eğer
ödenek...
sende raporların varsa raporları gönder. Print edeyim.
Tamam oldu.
Veya print et hemen alayım oradan.
Olur inşallah. Ben onları zaten print edip
İmzalayıp şey mi yapmıştın?
imzalayıp tarayıp
Ha, sen öyle yaptın. Şey koymadın. Ben soft copy üzerinden şey yapmıştım onları. İmzaladım.
ne yaptım acaba?
Onlarla alakası yok.
Sana işbirliği.
Onunla alakası yok.
Öyleyse
Görüntü uygun değil.
belki de oradan
Belki de bir yerlere koydun onları.
neyse.
ihtiyaç olacak.
Hocam ben bir derse gireyim de.
Tamam sen hadi dersini iyi dersen. Ne zaman bitireceğiz? 50 dakika.
50 dakika.
Görüşürüz.
Görüşürüz. Okay. This is the code. Sale class, sorry. And there is a virtual function here. And inside the savings, I am making two virtual calls. Okay. And this is a global function operator. Less than. It takes two objects, base class object references. And this is the implementation of everything. Okay, sale, setter, the constructor, bill just returns a price for the base class. Okay, get price as this, set price. Yeah, okay, I don't have to. Okay, so this, again, this is a virtual call, other.bill, second bill, first bill, virtual call. This is a virtual call too, okay? This is a virtual call too. So you might say that I am not calling this using the base class's pointer or reference, but in fact, this is how it is called. Okay. This is a base class pointer, this keyword, and you are calling the bill virtual function that way. Okay, this is how your functions are called. This is how it is done from the beginning actually. But we are not using this, but we are using the short form of it. These two are the equivalent. Okay, so all the two bills at line 52 and line 57, they are all polymorphic calls. They all will be decided during the during the runtime. Okay, discount sale is here. I have already discussed that. And implementation is, see, this overrides the bill function. This overrides the bill function, but it doesn't say anything about the less than operator. The less than operator is implemented here, and this less than operator is dependent only on the sale header. It doesn't say anything else. Likewise, the saving function. These two functions are generic functions. They will work for all kinds of sale objects, including the base class sale and a discount sale. Even though they don't know anything about the discount sale, they can work on the discount sale objects with no modification. That's what makes it generic. Let me go to the beginning of these slides. One, okay, polymorphism and virtual functions. Okay, that was the definition, right? I said generic coding or code reuse. We are going to use functions before they are defined. That was the meaning of the main motivation for the polymorphism. Okay, why? Because we are going to write functions like this. So I am calling a function that I did not define yet. I did not implement yet. Okay, because I don't know what kind of function I am going to call when I compile this code. When I compile sale.cpp, when it forms the sale.o, okay, I don't know what kind of bill functions I will call during the runtime. That's what makes the polymorphism interesting, and that's what makes these two functions generic functions. Okay, good. So let's look at the code that uses these two classes. Okay, I include sale and discount sale. Okay, and since I have used the namespace, I am using this Savage Sale namespace. I have a simple sales and discount sale. Simple sale is just price is the same as the bill, so $10 and the bill is $10. But this one is the price is $11, but I am giving a 10% discount. So if I drop this discount amount, I will take out $1.10. So the bill amount will be $9.90. So this discount object will be cheaper than the simple object, even though its price is more expensive than the price of the simple sale. Okay, so what do you think this if will return? I mean, this one will return true or false? Line 19, this less than operator, would it return true or would it return false? Anybody?
True.
It will return true. Why? Because if I call the discount less than simple, the implementation is here. First dot bill and second dot bill. What is my first dot bill? Discount dot bill. Discount dot bill will return 11 minus 10%. It is going to return $9.90, but this one will return just the price itself, which is $10. So this bill and this bill are calling two different functions, and I will make this decision during the runtime. So this will return true, and discounted item is cheaper, and I will print this out. I will say simple.savings. Let's look at that one again. Simple.savings bill of this object is $10. Okay, other dot bill is going to return $9.90, so it's going to be 0.10 cents will be printed on the screen. Okay, good. So this is second example. Let me go to the original book slides again. Okay, so the virtual works that way, and this less than operator and the savings function will do it that way. It's a very powerful. Okay, so the how does the virtual mechanism work? Okay, so it looks like it is complicated. It is not actually. I have shown you how the thing works under the hood. I gave you the v tables and etc. The compile will wait until the function is used in program, and it follows those links. Okay, overriding. Again, let's go back to the term overriding. Is different from redefining. They are similar in that they are involved with the inheritance. Okay, there has to be a base class, there has to be derived classes, and if the base class function is a virtual function, and if you are rewriting that function in the derived classes, then you are overriding it. So overriding are done with the virtual functions. For the non-virtual functions, you call them redefinition. Okay, so two different terminologies. In fact, C++11 makes this more explicit. It says that if you are overriding a base class virtual function, you put this keyword. It's a new C++ keyword, override. Okay, you put this keyword override at the end of the function declaration. You are saying that I am overriding a base class virtual function. Okay, so there is an override keyword. So you are making explicit to the compiler that this is definitely an overriding. You don't have to do that, but doing it is much better. Doing it much better. Let's say I don't have this keyword here. Let's say I don't have this keyword. Let's say I don't have it. Okay, if you don't have that keyword virtual in the base class function bell, then putting this override here will produce a compiler error. Why? Because the compiler will tell you that bill is not a virtual function. How can you override it? Overriding happens with only virtual functions. Okay, so this override keyword will help you catch those kind of errors. Okay, it will help you catch those kind of errors. Override keyword. Okay, and another C++11 keyword with the inheritance. You may say that I have a virtual function. Okay, I make this virtual, but I don't want anybody to override it. So I made it final. Final is a new C++11 keyword. Final is a new C++11 keyword. Okay, so you are saying that nobody can override this. So does it make any sense to make a function final, a virtual function final? Of course it doesn't make any sense, especially if you do it with the base class. Okay, base class. But let's say don't do this, but do it here, final. If you do it here, then any class that derives from discount sale cannot override this function bill. Okay, so the example that I'm giving is better than what the book says. Okay, it doesn't make sense to make a virtual function final in the base class. Why? Because why did you make it virtual then if nobody is going to override it? Doesn't make any sense. If there is only a single implementation of that bill, then make it static, make it non-virtual. Okay, why are you making it final? So making it final here is more explainable. More logical. Why? Because there are two implementations of the bill now, but I don't want that third implementation in a new derived class. Okay, good. Any questions so far? So, two new keywords, override and final. Yes.
If discount sale is another derived class which is derived from sale, and if discount sale have virtual function again, it makes any sense with final keyword.
Okay, so discount sale, you are asking the question about this slide. You are saying that discount sale is a class that derives from sale, and if it has another virtual function, you mean, or you are talking about the function bill?
I'm talking about bill.
Bill. So are you asking, can I make this virtual like this?
Yes, because I understood from final is I will not override anymore after discount sale.
Well, in the derived classes, it is up to you to put this virtual keyword in front or not, okay? And once a function is virtual in the base class, this one has to be virtual. You cannot make it the other way, non-virtual, okay? So it doesn't matter if it's virtual or not here, you put the keyword virtual or not. This bill is virtual. You cannot change that. And if we go back to the other box examples, and I think this one uses that notation. This one says that if somebody is virtual, then I am going to put that keyword virtual in front. Yeah, see, this is base plus commission employee, and earnings and print at the beginning, it says virtual. And if I like, I put a final here. It's okay. Well, in fact, in this case, I could have done it with the commission employee, right? That would be a good example. Since commission employee is between base plus commission employee and the commission employee, I can put a final here, okay, with the earnings. In that case, line, okay, for the base plus commission employee, this line 18 here, would produce a compiler error. For the C++11 only. For the C++11 only. Okay, good. Go back there. Okay, so two new keywords, final and override. Okay, this is a good question. The book says that if the virtual functions are so nice, so powerful, why don't we use them all together? I mean, why don't we make everything virtual? All the functions. In fact, Java, if you don't say so, okay, makes all the functions virtual by default. All the Java functions, they call them methods. All the Java methods of classes are virtual methods. They are all virtual. They are all decided during the runtime, okay, but the answer is this is expensive. Why? Because making a decision during the runtime is expensive. You have to follow the links and etc., that kind of stuff. Okay, so the C++ says that my default is non-virtual static binding functions. Java says that my default is virtual dynamic binding functions, because Java is not as careful as C++ when it comes to efficiency.
What if you use a line keyword in front of the virtual functions? Would it prevent the overhead during runtime?
Well, no, Kamil, you are kind of trying to find a solution for this virtual. No, Inline and virtual, that's a good point. Inline and virtual is kind of opposite things. When you say the inline, you know that I know the code, I know which one to call, okay? And I am not going to make this function call. Instead, I am going to paste the code in. That means that you know which function to call, right? You have your code in your hand. With the virtuals, you don't. During the compile time, you don't know which code to call, okay? Because you don't have it in your hand. Remember how we compile this? Okay, let's say I am compiling this sale class, 60 lines of code. When you compile this code, this bill, you don't know which bill to call, right? Is it the base classes bill or derived classes? In fact, I don't know if there are any derived classes yet. So it doesn't make any sense to make this bill an inline function because I mean, I don't know which one to call. I don't know which function to call, let alone the code contents of that function. So it doesn't make any sense to make a virtual function inline. I'm sure the compiler will give you at least a warning message, but most probably it will give you an error message. Doesn't make sense to make a function inline and virtual. Okay, that's a good line of thinking though. That's a good line of thinking. Can I combine these two? Does it make sense? Can I combine static functions and the virtual functions? Something like that, okay? Good, okay, so there is one design philosophy difference between C++ and Java. C++ is very preoccupied with, very fixated with efficiency. Everything has to be efficient because it is C. Java says that, no, I don't have to be that efficient. Okay, writing easy code, more maintainable, software engineering wise, write code is my philosophy. We'll talk about it later. So pure virtual functions, we talk about it. When you make a function pure virtual, you don't implement it, and that function will make the class of that function abstract. Question: does it make any sense to make a global function pure virtual? I like to do this, a global function. Let's say a void f that takes an integer, and I like to say this. I like to have a global function f that takes an integer, and I am not going to implement it. Does it make any sense? Any ideas?
I think not.
Why not?
Since it is a global function, it does not belong to a class or any interface. In order to work, it should be in a virtual function. I mean, a pure virtual
Abstract class, you mean?
class. Yes, class.
Yeah.
Yes, it's not meaningful.
It's not meaningful. Why? Because, I mean, we make some functions pure virtual in the base classes because our intention is we are going to derive new classes out of that class and we are going to implement those functions. How are you going to override a global function? So it doesn't make any sense. Okay, good. Abstract base classes, we talked about them. Abstract base classes for some people sounds funny. Why are you making a class if there are no objects of that class? But that doesn't mean that I cannot derive from that class. Okay, I cannot derive. That doesn't mean that I cannot derive that class. And that also doesn't mean that I am not going to use a reference to that class or a pointer to that class. Okay, this is definitely possible. This is definitely possible. I have an hourly employee HE, whatever the parameters are, and I have an employee reference HE. So ER is an employee reference. So I can use this ER like a regular employee object, even though I cannot make objects of employee. Okay, so I can do that. And this one is a polymorphic call, because why? Polymorphism happens when you make that function call using the base class pointers or base class references. And that's what I'm doing here. Okay, so this extended type compatibility, that is the ISA relationship. Let's return to it and let's talk about it a little bit more. And we will see this slicing problem again. So if I have a class sale, and if I am deriving from this class sale and call it discount sale, okay, so all the objects of discount sale is objects of sale, okay, there is an ISA relationship between them, and this is a one-way relationship. The opposite is not true. I don't say that all the objects of sale are discount sale objects. There is no the other way relationship is not valid. Okay, it's like friendship. If A is a friend of class B, that doesn't mean that B is a class of B is a friend of A, something like that. Okay, and there is no way I can do this. There is no way I can do this. You cannot in C++ or in any other object-oriented programming language. There is a ISA relationship between two classes, a symmetric ISA relationship. ISA relationship is always, with the inheritance, is always one way. Okay, one way. So the book is going to define two classes. In fact, let me show you this. Okay, good. There is a pet base class, very simple, stupid class. Okay, everything is public. It shouldn't be, but everything is public just to make it simple. So I have a pet, evcil hayvan. I have a pet. So the pet has a string name of the pet. Okay, and my virtual print function of the base class. And I have a dog class. Dog is a pet, which is right. Okay, and on top of this name data member, I put another one, breed, jins. Okay, and let's do this. Let's look at this code now. Okay, I have, let me, without drawing I cannot do this. Let me go to the book slides. Okay, when I declare these two objects, let's declare these two objects, dog and pet. And here let me okay, good. This is my memory. I have two objects. One of them is vpet, the other one is vdog, and inside vpet, okay, inside vpet I don't have anything. Okay, I have vpet pet, vdog dog. Okay, let's go to this one. Vdog name is tiny. Okay, name tiny, and breed is Great Dane. For the vpet, I did not initialize the name field. I don't know what this is. Okay. After I write these two lines, I am writing this one. First of all, is this a valid line? Can I assign a vdog object to a vpet? Can I assign a dog object to a pet object? Okay, remember the hierarchy. The hierarchy is like pet and dog, and there is a relationship between them. So all the dog objects are actually pet objects. That means that this is valid. I can do this. But how about this one? How about vdog gets the value of vpet? Is this allowable? Is this line okay? This line is okay because there is a relationship. How about this one? Is this okay? Vdog gets the value of vpet. The answer is, the way I ask you, the answer should be no, right? Why? Why? Okay, you tell me why. Why this second line, vdog gets the value of vpet, is not allowable?
Not all pets are dog.
Exactly. Not all the pets are dogs. There could be other types of pets. For example, a cat. It could be a quick cat, okay, etc. So this is not, there is no is a relationship that way, okay? Is a relationship, all the cats are pet, all the dogs are pets, and the opposite relationship, all the pets are dogs, no. Okay, so let's look at the meaning of this. vpet gets the value of vdog. Okay, inside vpet, okay, the size of vpet is smaller than vdog. So what am I gonna do? What am I gonna do is this. Okay, now for the name field, I can write this one and do tiny. For the breed field, I don't have anything to add here. So I lost some information with this assignment, right? So this is called, again, remember what I told you before, slicing problem. You could make this assignment. You could make this assignment, but did somebody ask a question? Did somebody ask a question? No? Okay. So I lost this breed field because I don't have any space to store that information breed field. So if you are doing object assignment using this is a relationship, you are losing that information. You are losing that information. So in order to prevent this problem, if you see this as a problem, maybe you could do this. Maybe you could do this. Okay, slicing problem is here. Maybe you could do this. Okay, here. Let's try to draw this memory configuration. This is my memory. Here is pet, a pet pointer. Initially it contains junk. Another one is pdog. Initially it contains junk, yeah. And then pdog gets a new dog. So I make a dog object here. Inside the dog object, I did not initialize anything, but this one, pdog, will point to this, right? And for the pdog, follow the arrow, name here, name is going to be tiny, breed is going to be Great Dane. Okay, so there's no problem. Then it does this. Okay, p pet gets the value of p dog. So let me use the green one. Okay, this is the green line. Okay, so it looks like I can do this. Why? Because there is a relationship. Opposite is not true, but there is a relationship here. Okay, so the question is this. After doing this, up to now everything is fine. The question is this. After doing this, can I write C out p pet name? Can I write this? Can I write this? P pet name?
Yes, we can write.
Yes, I can. Why not? Because the p pet as a class has a name data member in it. But how about this? C out p dog breed. Can I write this? Answer is of course yes. Why not? Because I know that p dog is a dog pointer and it points to a dog object and there is a breed field in it. I know that. But how about this now? This is a tricky question. Can I write this? P pet breed.
Yes, we can write again because there is a relationship.
Yeah, it seems that way, but the answer is no. You cannot. Think like you are the compiler. If you are the compiler, what kind of pointer is this? What kind of pointer is this? It's a pet pointer, right? If it's a pet pointer, it should point to a pet object, right? Let's go to the pet class. Let's go to the pet class and let's see if there are any. Let's go to the pet class. Okay. Let's go to the pet class and let's see if there are any breed data members or functions in it. No. So the compiler knows only this one. Compiler only knows this one. So the compiler has no other choice but giving you an error message. It's going to say that breed is not a data member of this pet class. You might say that, well, this is virtual function, this is polymorphism. Why doesn't it follow the link and see if there is a breed field or not? But let's consider this. Let's say I have another. Let's say I have another. My hierarchy is like this: pet. Draw it better. Pet, dog, and cat. Okay. Let's say inside the cat, I have the name and what do I have for a cat? Okay, maybe eye color. Okay. How about this? Can I write this p pet eye color? Because name boncuk eye color blue. Okay, this p pet can point to this one too, right? We don't know what kind of thing it's going to point to in the runtime. I cannot make this judgment saying that, okay, follow the link and try to find the breed field, and if it is there, print it. If it is not there, give an error message. No. Okay, I cannot do that kind of stuff during the runtime. During the compile time, that breed or eye color has to be inside the definition of the pet class. Okay, so this is both, these are both wrong. I cannot write these are illegal. Okay, so this is not doing any slicing problem. Okay, I don't slice anything, but even though I have an object of type dog that is pointed by a pet, I cannot access all of its fields. Okay, even though I do that. Okay, another question for you. Right after doing this, here I assigned a dog pointer to a pet pointer. Can I write this? P dog. Right after this, P pet. Is this okay? All I am trying to do is what?
Yes, it is. It can be done.
So what happened to our is a relationship? Is a relationship is a one-way relationship, right? I can assign P dog of, you told me that in a few minutes ago. You told me that I could do this, but I cannot do that, right? How come can you say it now? Okay, I know what you're thinking. You are saying that both P dog and P pet are pointing to the same object. If I do this assignment, right? I will assign the same thing to P dog, right? But no, because there is no direct is a relationship between P pet and P dog. Okay, not all pets are dogs. Let's say P pet is not doing this, but doing this. Okay, P pet is pointing to a cat object. Here is a cat. Does it make any sense to? Okay, I did it wrong. Sorry. Okay, get this out, and P dog is pointing here. Okay, now I am trying to point my P dog to a cat object, right? That's what I'm trying to do now. So this is a very dangerous thing. Okay, if you try to assign a base class object, a derived class object, you are doing a dangerous thing. Sometimes it will work, sometimes it won't, right? If I am lucky, if this P pet is using the green line, okay, then this will work. If it is using the red line, then it will not work, because P pet can point to both dog objects and the cat objects. But P dog can point to only dog objects, right? So this is not possible, directly not possible. Even though you know that if I am using the green line, even though P pet here is pointing to a pet object or a dog object, right? I cannot do that directly. Well, in C, you can force it to point to anything that you like because it is C, but we have to be careful. You don't want to run into problems like this is a very bad problem. This black line is a bad problem. If your P dog is pointing to a cat, okay, that's a very bad problem. You don't wanna do that. Okay, it's like pointing to a double with an integer pointer. Okay, so even though I get rid of the slicing problem using the pointers, using the that's not going to give me the right of doing this assignment in the opposite way. Always do your assignments with the arrow way. Okay, you could assign dog objects to pet objects. You could assign cat objects to pet objects, but you cannot assign pet objects to dog objects. Okay, or the pointers.
So this P dog gets the value of P pet is downcasting, right? We should be doing this.
We will talk about upcasting and downcasting. The important thing is assignment in the direction of these arrows is okay. But if you are doing the assignment with just the opposite direction, you have to be careful. It will sometimes work, sometimes it won't. Right? If pipette contains this green line, okay, that means that if pipette is pointing to a dog object, then this assignment should work. If pipette is pointing to this cat object with the red line, then this assignment doesn't make any sense. So what we are saying is all the dog objects are pet objects, but not all pet objects are dog objects, right? I am not saying no pet objects are dog objects. I am saying not all pet objects are dog objects. That's what I'm saying. Okay, so this is kind of an introduction to slicing problem. And why are we talking about this? Because there is something useful will come out of this. We will make sure that this pet pointer is pointing to a dog object, and I will make this assignment in that case. So there is a way of doing that, and I will cover that tomorrow morning. Any questions so far? Any questions? Okay, study hard for until tomorrow. Read the whole chapter about inheritance and the polymorphism. Okay, tomorrow we will finish up with this chapter. Okay, see you tomorrow morning.
Sir, can I ask a question?
Sure.
Do you know when will we get our midterm results?
No, I don't.
Okay, thank you, sir.